IP routing. The last session, IP routing is being started. IP routing is a process of forwarding traffic from one network to another network. IP routing is a process of moving of IP packets from one LAN to another LAN. When traffic is moving from one network to another network, it involves IP routing involves two basic activities. The one is finding best paths. So once you find the best paths, then later it's going to forward the traffic through best paths. Two basic activities: finding best paths, forwarding traffic through best routes. Right. So to implement IP routing, we have the basic rules are available. Conditions. So condition number one is router LAN interface IP address and like router LAN interface IP address can be Ethernet port, or it can be fast Ethernet, or it can be gigabit WADA. Router LAN interface IP address and end user IP address should be in same network address always. We use class A also, class B also, class A also, but condition is what, guys? Router LAN interface IP address and end user IP address should be in same network. Same condition, similar type of condition for all branches. The condition number one. Now, condition number two is like link between router 1 and one more, let's say router 2. WAN interfaces, WAN links, called serial ports. Like serial port between R1 and R2, both always should be in what? Same network address. Like head office router and branch office router, WAN links between should be in what? Same network address. Condition number three, like R1 LAN and R2 LAN. R2 LAN and R3 LAN, like whatever, R4 LAN, like all LANs should be in different network address, right? Like what happen if there is no different network address? Say if you use R1, R1 is a 10.0.0.0 network. If R2 also if using 10.0.0.0 network, what happened if you are not following condition? You know what happened here? See, first computer is trying to communicate with R2 first computer. So R1 first computer is a source and R2 first computer is a destination. Now tell me guys, what is the source network address? The source network is 10.0.0. Destination network address is what? 10.0.0. This IP packet is being generated. Like now, my PC, what they can think? Source IP, destination IP, both are in same network means, okay, destination is also, it may be in my same LAN, maybe in my, within a floor, within a room, within a building. So this destination, it is not in the outside means your packet will not go to router. Your packet is searching inside your LAN only. And how your traffic can reach a R2 LAN is not possible, right? This is a condition actually, right? The condition number three, condition number four, right? Condition number four is all interface of the router. All interface of the router, like a R3 serial port, R2 serial port, like all interface of the router should be in different network address. R1, one is LAN interface, serial 0/0, serial 0/1. Like total here, three interfaces. FE 0/0, serial 0/0, serial 0/1. Like three interfaces should be in a different IP network. For fast Ethernet, if we use 10.0.0.1, like we cannot make use for serial 0/0 again 10.0.0.2 or something. We have to make use what some other network like 90.0.0.2. Like for serial 0/1, again we cannot make use 90.0.0.3. It is not possible, right? Overlaps. Then what we do? We do something other like 190.0.0.3. Different network address should be. These are all the conditions. Like after conditions, now can go for implement a routing. So this routing can have a three types of routing, three process. One is what, guys? Routing types are what? Types of routing. Static, dynamic, and static routing, dynamic routing, default routing. Right. So the routing part. So which routing we have been covered now? Display class, which routing is covered? Static routing. So what is static routing? On the screen clearly showing here, static routes are configured, maintained, updated by network administrator manually. And to configure static routing, network administrator should know destination IP network. So we should know all destination IP network, and yesterday's session we clearly discussed like how your routing table is being forming, what is the default routing table entries are available, like how we need to update your static routes, now how traffic is moving from one network to another network. This is all the routing part clearly we have discussed, right? So there is our yesterday topic, static routing. So before static routing, WAN technologies we have discussed. So do you have any doubts on static routing, WAN technology? No doubts, right? Okay. And Saturday, 4th April, what topic have discussed? Configuration of router. Like how can configure router initially? Assigning host name, IP address, and passwords to create of a VTY console password. Any doubts regarding initial configuration? Like user mode, privilege mode, show commands. No doubts, right? April 3rd. 3rd April, what topic have discussed? Tell me the topics, guys. 3rd April, what topic have discussed? Introduction to routers. Like what is router, types of router, functions of router, router internal components, external components, like all about router part we have discussed, right? Okay. 2nd April. What topic we have discussed? 2nd April. Yeah, TCP IP, like how data transmission happen from one layer to another layer, like 7 layers. So each and every layer clearly had discussed, right? 1st April, IPv6, right? How IPv6 logics, subnet mask of IPv4. March 31st, IPv4 logics. So regarding these topics, do you have any doubts, guys? Any doubts? Hope no doubts, right? If we don't have any doubts, I have one doubt. Can I ask? All of you. I'm asking to all of you. I have one doubt regarding IPv4. If you are okay, then I'll start my question. What do you say? Right. My doubt is, my question is here. Let me ask my question first. So try to understand clearly what is my question. As soon as router configuration, do you have doubts? At end of the session, you can ask me. We'll discuss clearly. So let me continue with my doubt. Okay. Right. See, my question is here. Have an office. My office name is ABC. of you can hear me? My voice is clear? Right. So what my question is very important scenario to understand clearly. Repeat once again. So I have one office. Office name is ABC. Like in my office has some departments. Let's say my office is IT company. Some departments are available. Department names are sales department, HR department, IT department, marketing department. So four departments in my office. Okay, guys. So first department, which is sales department, have a 50 computers. Here I have a 50 devices. For HR department, 50 devices. For IT department, have a 50 devices. For marketing department, have a 50 devices. So my simple question is here, total how many devices are available in Office ABC? Okay, very good. Like four departments, like how many end user devices? Well, how many devices means what? 200. All right. 200 hosts are available, right? Now all 200 hosts are being interconnected with the switches and wireless access point, whatever. But now we need to enable communication means we have to assign IP address, right? So for all 200 computers, which class IP address do you recommend? Class A or class B or class C? Which class? Which class IP address? Class C. Why? Yeah, perfect answer. The thing is, if I use a class A IP address, for each network of class A IP address, we have 1677721 IPs are available, right? It's very large number. But our office ABC requirement is what? Only 200. So out of very large number of IP address, if I use only 200 IP address, remaining all IPs are wasted. So class A is not recommended. We go for class B. So for class B, each network of class B, 65,534 IPs are usable. That's a very large. 65,000 plus IPs are available, but our office ABC requirement is what? Only 200. So out of very large number of IP address, like 65,000, if we use only 200, remaining still 65,000 plus IPs are wasted. So class B also is not recommended. Like finally, which class is recommended means class C. You know why? Why? Because we have 254 IPs for each network, right? So even Office ABC requirement is what? 200. So nearest possible size is what? Class C. So now you tell me, guys, class C example IP address. So finally we have decided class C, okay, but tell me one class C network IP address. 192.168. Okay, right. So I'm also using this 192.168. Let's say 1.0. Now 1.0 is a usable IP address or network ID. 1.0 is what? Network ID. So what will be the broadcast ID of this IP address, guys? Broadcast ID is what? 192.168.1.255 is a broadcast ID. In between network ID and broadcast ID, between all are valid IP address. How many valid IP addresses are available? 254. Right? Okay, perfect. Now I'm going to use for sales department. For sales department, we have a 50 computers, right? So for sales department has started 192.168 dot. Let's wait some time and let me take. Okay, sales department 192.168.1.1 to 192.168.1.50 IPs are being used. Okay. For HR department, 192.168.1.51 1.51 to 192.168 1.100. Okay, guys. For IT department, for marketing department, 1.100. Here, say 150. 151 to sorry yeah 51 to 100. Here what 101 to 150, and here 151 to 200. Right. So this is my have assigned for all departments. So out of 254, 200 IPs are being used. So still, how many IPs are being left here? 54. Okay, no problem at all. Live with us. All of you, can you hear me? Right. Here my question is here. Now, sales department, HR department, IT department, marketing department, like all department computers can communicate each other. Yes. Why? What is the reason? Yes, they can communicate. Why? What is the reason? Why? Because all are in same network address, right? Same network. Yes. Now, all departments can communicate each other. Why? Because all are in same network address. Okay, perfect. But now my requirement, as per my requirement as a network administrator, my requirement is sales department should not communicate to HR. HR should not communicate to IT. IT should not communicate to marketing. Like inter-department communication should not be there. Each department should not communicate to which other department. Then what was the solution? Change network. Very good. Different network. Exactly. Okay. Let me change the network here. Like change the network means sales department from 1.1 to 1.50, HR department 2.1 to 2.50. For IT department, 3.1 to 3.50. Okay. For marketing department, 4.1 to 4.50. Now, each department communicate each other? No. Why? Why? Because here we have what? Different network addresses. So my condition is being satisfied. So my requirement is should not communicate. Okay, here I have used the different networks, no communication. So my condition is satisfied. The problem is what? So for each network, how many IPs are available, guys? 254. Out of 254, for sales department, how many IPs are being wasted? Here, 200 plus for sales. For HR department, how many IPs are wasted? 200 plus. For IT department, 200 plus. For marketing department, 200 plus. Like total, for 4 departments, how many IPs are wasted? 800 plus IPs are being wasted, right? So for 4 different networks, based upon our requirement, my requirement is being satisfied. But thing is what, guys? 800 plus IPs are wasted. So actually, this is what IPv4 size. In IPv4, we have 4.3 billion IP addresses. Out of 4.3 billion IP addresses, class E reserved for R&D. Class D IPs are reserved for what? Multicast. And we are making use only class A, class B, class A only. From class A, class B, class A, 0.0.0 network is minus global ID. 127.0.0 is minus loopback ID. Network IDs are minus. Broadcast IDs are minus. Remaining IPs only like worldwide, universally we have to make use. Like how many countries are available, how many usages are available, how many users are available, how many devices are available, like how much technology is developing every day. So do you think we have a sufficient IPv4 addresses? In IPv4 range is 4.3 billion. From 4.3 billion, class E, class D, both are reserved. We are not making use. Only ABC. From ABC also again what happened here? Two networks are minus 00, 127. Network IDs, broadcast IDs. So remaining IP address only we need to survive worldwide, universally. Is it possible, guys? No, it's not possible, right? So in 1990s, what happening is, so they understand the future, the next generation, we are running from out of IPv4 address, we require more number of IP address, we require very large number of IP address. So present we have IP address is a 32-bit address IP address, but we require very large number. Then we have introduced about what? IPv6 with 128-bit address. In 1990s, but still in 2020, even 2020 also, we are using IPv4 only for internet access. How it's possible, guys? Even after 2030 also, after 15 years, 20 years also can survive with IPv4. Even technology is being developed very fast also, we can survive. How is possible? Even after 20 years also, we can survive with class A, class B, class C only. As a network engineer, so that logic we need to understand. How we can survive with the help of IPv4 address only, and the next generation also means only the logic is these wastage of IP address we need to minimize. For 4 departments, 800 IPs are being wasted, right? So if you minimize that wastage, if you reduce that wastage, so you can survive easily, right? How we can minimize the wastage of IP address? How to reduce the wastage of IP address? Have a small simple scenario, general example. I'm giving apples to you. Who don't have a lunch can have it. Okay. One, two, right. Three, so fresh apples, right? Four apples. The example is here. Now our participants. The first one is right. Ankita. So I'm giving. She's asking only one piece from this apple. Only one piece enough. She's asking. Okay. So what I'm doing is let me add some apple here. I'm providing two. Right. After some time, like Minhas is asking, so I need one more piece. Right. Okay. Some second apple. I'm providing one more piece. Right. Mustafa is asking. Okay, Mustafa, take one more piece. Like Nagsiva is asking. Okay, I'm giving to Nagsiva. So four pieces okay, but what happened for me? So remaining entire apples are being wasted, right? It's a wastage. Now you tell me, guys, what is the best solution? How to reduce wastage? So don't take make a juice. Okay, Rakesh. So I need a pieces, right? Take only. It's okay. Can be used for others. There is no others. Have only four members is available. Have only four members. No others. There is no others. But present at meeting we have. At present meeting at we have still Punit Kumar is there. Pradeep is there, right? Okay. Jokes apart. Come to the main topic. See, instead of the four apples, what we'll do, guys? Divide into four parts. Have wastage here. The same logic. Our requirement is here. So for four departments, like sales department, HR, IT, marketing, instead of taking 1.1, 2.1, 3.1, 4.1, four different networks, we'll take only one network and divide into four parts. So if you're using four different networks, we have 800 plus IPs that been wasted. Right? So instead of four different networks, you can take only one network, divide into four parts, then no wastage of IP address. So why we are dividing four parts only? Why? Because office ABC requirement is what? Sales, HR, IT, marketing. Four departments are available. That's the reason I'm dividing to how many parts? Four parts. Maybe some other office XYZ. Some other company, office XYZ, we have a 10 departments. Then don't go with 10 different networks. Take only one network and divide into 10 parts. Some other office 1, 2, 3 have a like a 20 departments are available. Don't go with 20 different networks. Take one network and divide into what? 20 parts. So based upon our requirement, we can customize, we can divide a single network into multiple independent networks, a single network into multiple different networks. So dividing from a single network into multiple different networks, this process we call what? Guys, we call it is a subnetting. Okay. So now you tell me guys, what is subnetting? What is subnetting? Subnetting. Subnetting is the process of dividing one network into smaller different networks. Yes, exactly. Segregating our network. One network has been segregated. Partition. So dividing a single network into multiple smaller networks called subnetting. So if we got the clarity about what is subnetting, now you tell me guys, why we are doing like this? Why subnetting is required? To avoid IP wastage, right? Perfect, Minas. Save IP addresses, wastage of IP address. Perfect. Right answers. That's it. So that is our class today. Our class has been finished, completed. Only two questions. One is what? What is subnetting? And second one is why subnetting. So what is subnetting means? Your answer is what? Dividing a single network into multiple independent networks or multiple different networks called subnetting. And why subnetting? To minimize the wastage of IP address, to reduce the wastage of IP address. Two questions. The thing is, how to minimize it? How to reduce it? What was the logic behind that IP addresses? So that's logics we need to let me discuss clearly. Okay. So coming to notes, you can copy the notes. Creating multiple independent network from a single network. Convert host bits into network bits. Subnetting can performed in a two ways. One is FLSM and VLSM. Pixel and subnet mask and variable and subnet mask. Subnetting can done based upon what? Requirement. So based on what requirement? Based on network requirement, based on host requirement, based on Cisco/rotation requirement. So entire subnetting can done based upon what guys? Based on requirement only. Like maybe some office requirement is 200, maybe some office requirement is a 4 subnets, maybe some office requirement. It depends upon the requirement of our companies. The real time in your commercial purpose, like in your industrial purpose, service providers, internet service providers, and very large companies. So for those, this subnetting is very useful. I repeat once again. So subnetting is very useful for what? Large companies, service providers. For service providers, they have a number of customers are available, right? Then what service providers will do? Will customize the network, will divide the network, and distribute to customers. The same thing for large companies also. So for large companies and service providers, the subnetting is very useful. Is the note. It is very useful for what? ISP, large organizations and companies. Okay, you can copy these notes now. So based on the same example, let me continue our topic. Now, Office ABC requirement is what? Departments. HR, IT. Means how many networks are required here? 4 networks are required. If we use 4 networks, what is the basis of IP address? 800 plus. Then what we need to do? Don't go with the 4 different networks. You can take only one network and we'll divide into what? 4 parts. Let me do that calculation. How to do it? So for Office ABC, we have decided to assign a Class C network. Network is 192 dot 168 dot 1 dot 0 is what? Network ID. 192 dot 168 dot 1 dot 255 is what, guys? Broadcast ID. I request to all of you, take white page and paper, pen and paper, and do the calculation the same. In the middle, I'll give you some task to you also. Try to work out on it. The best practices. Be ready with pen and paper. Okay. So 1.0 is a network ID and 1.255 is what? Broadcast ID. In between, all IPs are usable or valid IP address. Valid IP address. How many valid IP address? 250 for a valid IP address. And what will be the subnet mask of this all IP addresses? Subnet mask is 255.255.255.0. Right, guys? So here we have a 4 terminologies. The terminology is what? The first thing is a network ID. Network ID. And second one is a broadcast ID, valid IP address, and subnet mask. So this is your complete one network, one major network or one parent network. This one network we can call, right? So from network ID is 1.0, broadcast is 1.255, 254 IPs are valid, subnet mask is 255, 255. This is one network. So from this network, based on our organization requirement, we are going to customize, we are going to divide. If Office ABC requirement is what now? They need a 4 subnets. There is 4 networks, right? Now divide into 4 parts. If some office requirement is a 10 departments, then what will you do? divided into 10 parts. Right? So based on requirement, I repeat once again, based upon what? Requirement only. But our example now, office ABC. Requirement is what, guys, here? How many departments are available? 4. So now, let me divide into 4 parts. Right. So now we have divided into what? 4 parts. So once it is divided, like each space, like each part we call, this is sub network. Subnet. It is not a network now. Network is divided into what? Sub networks. The short form we call what? Subnet. The first subnet, and have one more second subnet, and this is a third subnet, and fourth subnet. So once we divide into 4 parts, we each part we call what, guys? Subnet. If it is not divided, then you can call it what? Network. So one network is being divided into some parts we call what? Subnets. Very important point is here. First subnet for sales department. Second subnet for HR department. Third subnet for IT. Fourth subnet for marketing department. Like a distributor, segregated. The main question is here, for sales department first subnet, what will be the network ID, what will be the broadcast ID, what will be the subnet mask, and what will be the how many valid IPs are in here. These all calculations we need to do for each subnet. For first subnet, what will be network ID, and what will be the last usable IP address, and what will be the broadcast ID, and in between how many valid IPs are available. If it's a major network, how many valid IPs are available? 254. But it's been customized. For each subnet, how many valid IPs are available, and what will be the subnet mask. So for major network, for parent network, subnet mask is what? 255.255.255.0. It is being divided, right? So what will be the subnet mask of first subnet, second subnet, third subnet, fourth subnet? So for each subnets, we need to do calculations. Let me start it. Two power zero value. 2 power 1, 2 power 2, 4, 8, 16, 32, 64, and 128. These are values, right? Binary bit value. Whatever. So first our calculation based upon what, guys? Number of networks required. Number of networks requirement. So for number of network requirement, generally we use one formula is 2 power n. 2 power n greater than or equal to. Formula is 2 power n greater than or equal to. Require. Right. 2 power n greater than or equal to requirement. This is our formula for what? Number of network requirement. Now, based on our example, Office ABC. Office ABC requirement is what, guys, now? How many networks are required? Office ABC requirement is what? 4. What was the formula? 2 power n greater than or equal to requirement is a 4. Now, which n value will be satisfied here? 2 power which n value? We go for 2 power 0? No. 2 power 1? No. Will be satisfied here? 2 power 2. So 2 power 2 greater than or equal to requirement is 4. 2 power 2 value is what, guys? 4. So what is the 4 indicates here now? So 4 indicates means one network is being divided into how many parts? 4 parts. So each part technically we call what? Subnet. So we call this a 4 subnets. 4 subnets. So this is our first step. Step 1 we have done. Next step. Our base example is what? 192.168.1.0 is a network our base example, right? So what will be the subnet mask of this IP address? 255.255.255.0. 255 dot 255 dot 255 dot 0. So can you please tell me 255 255 25.0 in a binary language? How can I write it? Binary 1 255 means how many ones? 8 ones. 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8 dot zeros 1 2 3 4 5 6 7 8. Now back to our subject, like a what is subnetting? Creating multiple independent network from a single network. The same time here, the second point is what? Converting host bits into network bits. So how can divide one network into multiple different network means what will you do? Convert host bits into what? Network bits. That is what? Convert zeros into ones. Zeros into ones we need to convert. Like how many zeros, how many ones you need to convert? So it depends upon your power value. To power value. Like 2 power value is what here? 2. Then we convert 2 bits. If power value is a 2 power 5, then convert 5 bits. If power value is a like a 3, then convert 3 bits. So How many bits we need to convert? How many zeros into ones means? This depends always what, guys? Power value. So let me convert zeros into ones. First zero, second zero is been converted to what? One. Okay, after conversion, again you have a one subnet mask, right? Like all ones is a 255 dot 255 dot 255 dot. First bit value is 128, second value is 64. 128 plus 64 is what? 192. So before dividing, before customized, before subnetting, we have one subnet mask. So that subnet mask we called DSM, default subnet mask. Like once it's subnetted, once it's customized, we call it is a CSM, customized subnet mask. Default subnet mask and customized subnet mask. So now we got the subnet mask also. Let's consider it as a step 2. For each subnet, I only have 4 subnet. For each subnet, how many usable IP addresses? How many valid IP addresses? Let me calculate it now. To power number of host bits. To power number of host bits is minus 2. The formula. To power number of host bits. How many remaining host bits are available? Means 2 power 6 minus 2. 2 power 6 is what, guys? Value is 2 power 6 what? 64 minus 2. Why minus 2 here? Why minus 2? Network ID and broadcast ID. Perfect. The two IPs are minus. So 62. What is 62? 62 host. Okay, but instead of 62 host, we can write as a 62 valid host, right? 62 valid host for each subnetwork, not a network, for each subnetwork, right? But total number of IPs are what? 64 valid IP address, 64 IP address. Out of 64, how many are usable? 62 are valid. So 62 valid host for each network or each subnetwork. For each subnetwork, right? So whatever I have done here, one network is divided into 4 parts. Now each part we have 62 IPs are available. And for each subnet, we have IP subnet mask is 255.255.255.192. But now we need to calculate what was the network ID, broadcast ID for first subnet. If it is not divided, directly can say 1.0 is the network ID, 1.25 is the broadcast ID. Here we have what? 4 subnets, right? For each subnet, what will be the network ID and broadcast ID? To find out network ID, broadcast ID is very, very simple. Try to understand here. Base example is 192 dot 168 dot 1.0, right? So in our networks are converted, which one is a least converted bit? 128 or 64? Which is the least converted bit? 64 is the least converted bit, right? What I'm doing is here 192.168.1.64. 64. Again, next IP address 192.168.1 dot plus 64. Add on the 64. Keep on adding 64, 64 like this. 128. Again, 192, 168, 1 dot plus 64. 192. Like how many times we need to add 64, 64 like this? How many times we need to add? Not 4 times, not 5 times, not 6 times. You keep on adding until you got the invalid IP address. Until invalid IP address, yes. So again 64, let me add here. 192, 168, 1 dot. If I add plus 64, I'm getting here 256. So 256 is valid IP address? No. So we need to stop here actually, right? So stop here. Now try to write before this IP address. What is the before this IP address? 192.168.1.255. Before this IP address, 192.168.1.191. Before this IP address, previous IP address is 192.1.127. Before this IP address is what, guys? 192.168.1.63. So finally, 256 is invalid. Try to remove it. So these all are left side are network IDs. The right side all are in a broadcast IDs. Is the first subnet range, its second subnet range, its third subnet range, is the fourth subnet range. 1.0 to 1.63, between how many IPs are available? 62 IP address. So what does it mean? 1.63, is it valid IP address, guys? No, it's a what? It's a network, it's a broadcast ID. Now what about a 1.128, is it valid IP address? 1.128 is valid? 1.128, no, it's not valid. What is this 1.128? The network ID, right? Like this. Now we are using only one network, which is 1.0. So one major network is being customized to 4 different networks. Now, first one, second one, third one, fourth one, 4 are different networks. They don't communicate actually, they don't communicate. When if we use customized subnet mask, or if we use a default subnet mask, now all IPs can communicate. Okay, guys? So this is how we can divide a single network into multiple independent networks. This process we call what? Subnetting. Take a clear notes on it. Copied. Now, okay, do it fast. And the power y2 here means a requirement is 4, right? So 2 power 2 is a 4. So satisfaction. Example, my requirement is a 16. My requirement 16. So which n value will be satisfied here? 2 power 4. 2 power 4 is what? 16. So your requirement should be greater than or should be what? Equal to. Right. So you just keep on adding. You just keep on adding, which is the least converted bit here. 64 is the least converted bit, right? 64 is the least converted bit. So 1.0 plus 64 plus 64 plus 64 and again plus 64, 192, 168, 1.256. So 256 is invalid, right? Stop here. Now how to write the broadcast ID is before this IP address, previous IP address means 256 before number. 255 is number, right? So I'm writing here 255. Okay. Now 192 before number is what? 191. 128 before number is what? 127. 64 before number is what? 60. So these all are broadcast IDs. They all are what? Network IDs, right? Right, good. Now 256 is removed. 256 is invalid. Okay, coming to step 2 about CSM. CSM here. So 192.168 1.0, our base example. So means is a class A, class B, or class C. It's a class C, right? So class C example, Mac, sorry. Class C subnet mask is what? 255, 255, 255, 0. No, class C 255, 255, NNNH, right? The default subnet mask we call. 255.255.255.0. We convert into binary language 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4, 5, 6, 7, 8. So these are subnet marks. So subnetting is converting zeros into what? Ones we need to convert. Like how many zeros, how many ones we need to convert? Office ABC requirement is a 4. So 2 power 2 greater than or equal to requirement is what? 4. Now n value is what, guys? N value is a 2, right? Means convert 2 bits. First bit and second bit is converted. If n value is a 3, then convert 3 bits. So how many bits we need to convert depends upon our always what? Power value. Now here power value is 2. I'm going to convert what? 2 bits. So first bit value is a 128. Second bit value is what? 64. 128 plus 64 value is what? 192. So remaining as is 255 dot 255 dot 255 dot 192. Like how we can decide power value? The reason before starting calculation, I clearly define the formulas: 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, 2 power 7. From this table, like entire subnetting, always you can get the values from this table actually, right? So 2 power 0, 1, 2 power 1, 2, 4, 8, 16, 32, 64, 128. Now my requirement is, example, my requirement is a 12 subnets. Fine. 5 new. And requirement is what? 5 subnets. And what is the formula, guys? 2 power n greater than or equal to what? Requirement. What is our requirement? 2 power n greater than or equal to requirement is what? 5. Now how can decide the power value? So UR is a requirement is a 5 means it should be greater than or equal to, right? If I go for 2 power 2, value is what? 4. But my requirement is 5. Can I get exactly 5? No. It should be greater than also. Then go other value is what? 3. 2 power 3. 2 power 3 greater than or equal to requirement. 2 power 3 is what? 8. My requirement is 5, but I can get possibility is what? 8 subnets. 8 subnets. Now power value is what? 3. So convert 3 bits. Means 128, 64 plus 32. You can get values what here? 224. Clear, Pradeep? The point? Right, perfect. Clear, all of you? Right, now, all of you do your task is now, this is a part now. So take a paper and pen and paper. Now, your task is number of network requirement. What's the formula? 2 power n greater than or equal to requirement. So office XYZ requirement is 30. That is requirement. Your base example is 192.168.25.0. These are examples of I. Now do the step 1, step 2, step 3, and step 4, and tell me the answers fast. Do it fast. All right. Answer please. First question. Number of subnets. How many number of subnets? Power value is 5, but number of subnets are what? 32 subnets, right? But our requirement is what? 30. Out of 32, we can use 30. 2 more extra, no problem. Okay, 32 subnets. 2 power 5, oh good. 2 power 5 is a satisfied value. Second question, what will be the customized subnet mask? Customized subnet mask. 255, 255, 255 dot 2, 240 or 248? Okay. Right. Number of hosts Total number of hosts. Total number of hosts. Total number of hosts are how many? Total number of 8 hosts. How many usable hosts? Valid hosts are what? 6 are valid. Good. Fine. Can you tell me second subnet range? Second subnet, okay. Second subnet range. Second subnet range. Network ID, broadcast ID. Second subnet. A base example 192.168.225.0. Very good. First step, 2 power n greater than or equal to requirement is 30. 2 power n value is a 2 power 5. 2 power 5 is a 32. So 32 we call is a subnets. 32 subnets. And customize default subnet mask is 255.255.255.0. If we convert 1, 2, 3, 4, 5, 6, 7, 8, like power value is 5 and convert to 5 bits. Okay, 1, 2, 3, 4, 5 bits. 128, 64, 32, 16, 8. If you add it, it's 248, right? The customized subnet mask is 255.255.248. And remaining host bits are 3. So 2 power 3 minus 2. 2 power 3, 8 minus 2. 6 valid host per subnet. So first subnet range is a 192.168.25.0, and second subnet 192.168.25 dot least converted bit is a 8 and 25.8 plus 8 plus 8. Keep on adding, so you can get now 25.16. So 25.7 is a first subnet range. 25.15 is a second subnet range. So 25.8, 25.15. Between we have 6 IP addresses are usable is 25.9, 10, 11, 12, 13, 14. Even 8 is not usable, 15 is not usable, right? Clear, guys? So this is all about the first step, number of networks required. Clear? Now let me discuss now. Second point is a number of host requirement. So just now, up to now we have discussed number of networks required. Now let me discuss number of host requirement. Number of host requirement. So number of host requirement is a formula. 2 power h. H indicates what? 2 power h minus 2 greater than or equal to requirement. Same formula for number of networks and the number of hosts also, but here the thing is only minus 2. In number of hosts, number of networks calculation for n. What was the first step we have calculated? Subnets. So why first subnets means a requirement is what? Number of network requirement. But now requirement is what, guys? Number of hosts. So first step also need to go for what? Number of hosts. Example, office ABC. My office requirement, office ABC host requirement is an 12 IP addresses, 12 hosts. Let me take the chart, your table, formula table. You can understand easily. Right. Okay, guys. So first step, 2 power h minus 2 greater than or equal to a requirement is what? 12. So what h value will be satisfied here? Requirement is 12 minus 2. 2 power 3 will be satisfied? No, 8 minus 2, 6. But I require 12, right? You can go for what? 2 power 4. Okay. 2 power 4 minus 2, 12. 2 power 4 is what? 16 minus 2. Why minus 2 here? Which is very, very important question. Number of times I'm telling. Minus 2 for what? It'll surely ask interviews and surely will ask in Cisco exams also. So always we are doing minus 2 for number of host requirement. Why? Because one for network ID and one for broadcast ID. Okay. So out of 16 IP address, we did minus 2. Then how many are valid IP address? What we call 14? 14 valid host IP address for each subnetwork. 14 valid IP address for each network actually, right? Okay. The first step. Next one. Now let me take our base example 192.168.63.10 is more 63.0 is our example. Two five five dot 255.255.0 is a default subnet mask. 1, 2, 3, 4, 5, 6, 7, 8. Out of 8 hosts, how many bits we need to convert now? How many bits we need to convert? 4 bits, right? But how can convert? The method of convert is very important here. In number of network requirement, we got converted from like left to right, right? Like 1, 2, 3, like in this direction. But now, when we are converting number of host requirement, like right to left, we need to convert. Right mode best. Like 1, 2, 3, 4, like this, right? It is very wrong. Very wrong. Not like this. It's not at all possible to convert this. You know how to convert in the number of host bits means, yeah, power value is a, like h power value is what? 4 means, just leave 4 host bits. And remaining all we can convert. Example, 2 power 2, power value 2 power 2 minus 2 is equal to requirement. Power value is what here? 2. So means what we need to do? Leave the 2 zeros, remaining all we need to convert. Value is a, like 2 power 6. Now 1, 2, 3, 4, 5, 6. Leave the 6 zeros and remaining 2 into convert. Like this. But as for our example now, what is the power value here? 4, right? So leave just 4 zeros. Leave it and convert remaining. 1, 2, 3, 4. See, in this example, actually here, number of host bits are 4. Number of network bits are 4. But it's not possible for all scenarios. Right? Okay. I'll see customize subnet mask. 255 dot 255 dot 255 dot 128 64 32 plus 16. Total was what? 240 is a customized subnet mask CSM. So what will be the step 2? The step 1 here, step 2 it is, and what will be the step 3, guys? What we need to calculate now? What we need to calculate for step 3? Pradeep, we got already calculated for what? Number of hosts already we calculated, right? Step 1 we calculate valid host. Step 3 is what? Number of subnets. The formula is 2 power number of network bits are converted. 2 power number of network bits are converted. How many number of network bits are converted here? 2 power 4. 2 power 4 is what, guys? 16. 16 is what? 16 subnets. Not host. Host we already calculated. Here 16 subnets. Perfect. Go for network ID and broadcast ID ranges 192, 168, 63.0. Now here least converted bit is what? 16. 192.168.63.16, 192.168.60. Plus 16. 32. Like, in the calculate. 192.168.60. Plus 16. Okay, 48. 192.168.60 plus 16. 64. Like you keep on adding, we can get how many subnets here? 16 subnets, right? Broadcast IDs 63.15, 63.31, 63.47, 60.65. Like you keep on adding actually. Right, guys? Minus 2 we already done, right? The first step we done what? 2 power h minus 2. Network ID broadcast already removed. So Here this is subnets. Subnets are no -2, right? -2 only for host. Network ID and broadcast ID host. Okay. So this is a calculation for number of host requirement. You can copy it clearly now.
One question.
Yes, please.
Sir, is it like power H minus 2 we did, so we know we remove one broadcast ID and network ID. So minus 2 already we did. But now in step 3 we are calculating like how many subnets. So is it because it is subnet within a subnet? That's why we have, because already removed -2, we are not calculating here one more time.
So always in the number of subnets, we don't need to remove the subnets actually, right? No -2. So -2 only for host calculation, not for the network calculations. Okay.
Didn't we do that when we did for?
So in the previous example, also 4 subnets, we did -2, right? 2 4 subnets.
Yes, sir.
But we done -2 only for what here?
Oh, host
In
bits.
host portion. Number of hosts only -2 here, right? 62.
Okay.
So -2 always only for number of host calculations. Why -2 also? One for network ID and broadcast ID. Right?
Got it. Yeah, thank you.
Copied, guys. This is number of host requirement. If we copied and give one more task to you. Let me give one more task to you. Number of host requirement. Same formula. Only 2 hosts. This is my requirement. Table. Do it fast now. Here, base example is 192.168. 9.0. Finished. Two power h minus 2 greater than or equal to requirement is 2. What will be the h value, guys? H value is what? 2 minus 2. So 2 power 2 is a 4 minus 2. Exactly can get what? 2 valid host per subnet. Right? Okay. My requirement is also 2 IP address I need. Subnet mask, class C subnet mask. 255, 255, 25.0. Like 1, 2, 3, 4, 5, 6, 7, 8. Now how to convert? What will be the customized subnet mask? 255, 255, last 2 bits. Last 2 bits you can keep the zeros, leave it. Last 2 bits leave it, and remaining all need to convert, right? Because your 2 power h value is at 2, so leave 2 zeros. 4 value is what now here? 2. So leave 2 zeros and convert 1, 2, 3, 4, 5, 6. That 6 means what? 128 plus 64, 32, 16, right? 8 plus 4. Well, how much? What is the value here? So 255 dot 255 dot 255 dot 252 is a customized subnet mask. Now how many bits are being converted? Network bits are converted. 2 power 6. 2 power 6 is what? 64 subnets. Subnets are 64. Okay, network ID and broadcast ID 192.168.9.0. 192.168.9 dot. Least committed bit is what? 4. 192.168.9 dot. 8 plus 4. 92.168.9 dot plus 4. 12. 192.168.9 dot plus 4. 16. Like and keep on adding. We can have how many subnets? 64 subnets. So let me write here now broadcast IDs 192.168.9.3, 192.168.9.7, 192.168.9.11, 192.168.9.15, like this. Like here 192.168.9.19. Can you hear me, all of you? See, I have one small question. Question is, from first subnet, 9.0 is a network ID, 9.3 is what? Broadcast ID, right? So from first subnet 9.0, 9.3, in between have a two usable IP address. What is the first usable IP address? first valid IP address 9.1 and last usable IP address 9.2. The two IPs are only usable. Generally, where we use two IP address, you know, guys? You know where we use? Why our requirement is a two requirement? Yes, Pradeep, perfectly all right. So where we use it two IP address means. Let me draw some diagram, network diagram. End user 1, end user 2, end user 3, end user 4. Like all end devices are connected to your router, is D-Link router through LAN ports from ISP. From ISP on cable will come to your WAN port. To WAN port. ISP also what? WAN port. This is C1 means customer 1. Customer 1 link network. C1 customer 1. Same like a customer 2. Customer 2 network. Customer 2 also connected to it. Service provider. Which link? WAN link. Like one more customer. This is customer 3. Right? It's also WAN port. Now what ISP is doing is, so ISP want to provide one IP address to customer 1, customer 2, customer 3, customer 4, customer 5, number of customers. If ISP using a different networks, IP bases, then what ISP is doing is, ISP WAN interface and customer WAN interface both should be in same network address, right? So customer WAN interface IP address and ISP WAN interface IP address both should be in what? Same network address. How many IPs are required, guys, here? How many IPs are required? Two IP addresses. So what they're doing is a 9.1 for customer, 9.2 for ISP WAN port. A network ID is a 192.168.9.0 is a network ID and 9.3 is a broadcast ID. Right? So usable customer 9.1, 9.2 they can use it. For customer 2, like 9.3 can make use. No, 9.3 is what? Broadcast ID. 9.4 I can use. 9.4 we can use. No, 9.4 also you cannot make use, you know why? Because 9.4 is what? Network ID, right? So here 9.5 for customer, 9.6 for ISP. 9.5 and 6 you can use what? ISP. So what is the network ID between customer 2 network ID? 192.168. 9.4 is a network ID. Right? What about customer 3? C3, customer 3. So for customer 3, 9.7 you can use. No, 9.7 is what? Broadcast ID, right? Okay, 9.8 you can use. No, 9.8 is also what? Network ID. Then you have to use what? 9.9 for customer, 9.10 for ISP, right? 9.9 and 10. Two IPs. What is the network ID of here? 192.168. 9.8 is the network address. Like this, customer service providers will provide IP address to customers. For all customers, what will be the subnet mask, guys, here? Yeah, Mustafa, what is your question? How about IP address of the networks C1 and C2, right? No, C1 is our other customer, C2 is other customer. There is no communication. C1, C2 is not in the same network, right? C1 is a different network, 9.0 network. C2 is a 9.4 network. And C3 is what? 9.8. Here, the three different subnets is there, right? They're not in the same. Even C1 and C2 want to communicate, they can communicate via ISP only. C1 end users. Okay, I got the point yours. C1 end users, you can make use any IP address. Like you can use here 192.168.1.0. This is your LAN. So LAN IPs are being assigned by network administrator. I'm talking about only here WAN interfaces. So within the LAN, you can use any IP address, no problem at all, actually. Okay. Right. So like this, we can use two IP addresses per. Even in the last example, in the last session, the last class, yesterday class, we have discussed some topology, right? Head office, branch office, head office, and branch office 2. Now between head office and branch office 1, you have WAN link, serial 0/0, 0/1. Both should be in what? Same network. So here I'm using 60.111, 60.112. If I use two IP addresses, but even I'm using class A, right? The class A, we have 167.2.2.1.4. Very large number of IP address have used only two IP address. How many IPs are wasted? Is it good? No, don't use a direct network. Customize it based upon requirement. Customize it, and you can, right? So mostly two IPs you can use for point-to-point connectivity, like R1 point and R2 point. Like point-to-point connectivities, we use what here? Two IPs. Okay, guys. So this is all about number of networks required, number of hosts required. Now finally, we'll try to discuss Cisco/notation, and we'll close the session for today. Okay, let me start with Cisco/notation. N indicates network indicates ones, host indicate what? Zeros, right? In yesterday class, when we configured routing table, static routing, have you seen routing table entries? When you see the routing table, show IP route. /8/24 something is showing, right? So that is that topic we are going to discuss now. What is slash notation? Cisco slash indicates what? Slash notation indicates number of network bits. Number of network bits. Not number of networks, number of network bits actually, right? Suffix. Keep in mind this point. Slash notation indicates always number of network bits. Now my requirement is a /1. What is /1 indicates? One number of network bit, right? So if we say /1 means one number of network bit, first bit, convert to 1. First bit value is what, guys? 128. So /1 indicates 128 dot second octet zeros, 0 dot third octet zeros, 0 dot fourth octet zeros, 0. Like 128.0.0.0 is a /1. Okay. Right. What about /2? So /2 indicates two number of network bits. Let's convert one more bit. 64. 128 plus 64 is what, guys? 192.0.0.0.0 is a /2. /3. Three number of network bits. Convert one more. 32. 224. 224.0.0.0. /4. Four number of network bits. 4 bits. Plus 16. 240. 0, 0, 0. Right? /5. 5 network bits. Plus 8. 248 dot 0 dot 0 dot 0 /6. 6 bits. 1, 2, 3, 4, 5, 6. 6 network bits. Last value is what? +4. 248 plus 4. 252 dot 0 dot 0 dot 0 /7. One more bit. +2. 254 dot 0 dot 0 dot 0 /8. /8 is what, guys? 8 network bits plus 1. 255 dot 0 dot 0 dot 0. Clear? Now what about /9? Is it valid? /9. So /9 means what? 9 number of network bits. First octet 8 bits already is there. I need one more bit. Let's convert one more bit. 128. So 255 dot 128 dot 0 dot 0 is a /9. /10. 255 dot 192 dot 0 dot 0 /11. Like 255 dot 224 dot 0 dot 0. Like this we can understand exactly slash notation. Okay. So now you tell me, guys, what will be the /16 subnet mask? /16 means 16 network bits. 8 plus 8. 8 means 255, right? So /16 is a 255 dot 255 dot 0 dot 0. Perfect. Now my requirement is a /24. This is /24 subnet mask. 24 network bits means 8 plus 8 plus 8. So slash 24 is a 255 dot 255 dot 255 dot 0. Perfect. Now, example here, have an IP address. IP address is 10.1.2.9. Actually, what is the subnet mask of this IP address, guys? 10.1.2.9 is a class A. What is the class A subnet mask? 255000. So this 25000 in slash notation, how we can indicate? 10.1.2.9 slash 8 if I indicates, and first octet is a 255. Like have a 172.16.1.1. Now tell me slash notation of subnet mask here. 172.16 is a class B slash 16. Same point in your routing table also, which is showing clearly here. If IP address is 10.00 slash 8, for all class A IP address showing what? Slash 8. 192.168, like subnet mask is slash 24. So what is the subnet mask of slash 25 slash 25 subnet mask? Yes, please. Slash 25 is what? 255 dot 255 dot 25 dot 128 is a slash 20 slash 18 slash 18 slash 18 1 8. We know slash 16, right? 16 is a 255 255, but my requirement is 18. Means how many more are required? Two more values. So what is the two more values? What is the second value? 192. Means here 255 dot 255 dot 190 dot 0. Right. Guys? Which is very important question, certification question. 255 dot 255 dot 230 dot 0. The subnet mask is default subnet mask or customized subnet mask. Everyone is a wrong answer. You know what? So this is a, it's not a default subnet mask. It is not a customized subnet mask. You know why? So why? Because subnet mask is only the possible values are 128, 192, 224, 240, 248, 252, 254, 255. So these values only the possible of subnet mask. It can be customized or it can be a default. So subnet mask possible values only what? 128, 192, 224, 240, 248, 252 and 254 and 255 only. So 230 is not at all possible. So here the same values will be repeated in a second octet. Here 128, 190, 224 up to 255. The same values will be repeated in a third octet. The same values will be repeated in octet, fourth octet. So subnet mask possible values only these values, right? So what about 230? 230 is a invalid. It's not valid. It's not at all possible subnet mask. So this type of the same question will ask in India Cisco examination. Same question 230. I have faced lot of times. Same question I have seen lot of times actually. Like slash notation, based upon slash notation, subnet mask we can understand clearly. Now we'll discuss the main concept of subnetting in Cisco slash notation example. Based upon slash notation, let me discuss our subnetting classes mainly. One 192.168.63.63/27. This information is been given by in exam. This is the task is given exam, or maybe this is the task given by interviewer. So this is the task. No, Rakesh, let me wait. It's not a invalid. Let me explain clearly. Okay, fine. It's invalid, right? But how we can say it's invalid? Let me explain here. This is the task is given for exams or interviews or whatever. Like in the companies also, this is your task. This is your requirement. 192.168.63.63/27. So based upon this information, no problem, Rakesh. So no, based upon this requirement, based upon this information, we need to calculate question number 1. Number of subnets. Question number 2. Total number of hosts. Question number 3. Number of valid hosts. Question number 4. What will be the customized subnet mask? Question number 5. Is it valid IP address? Yes or no? 5 questions. 50 marks. Try to do it fast now. Let me see now how much score you can get secure. Anyone can answer? 5 questions. I think you can easily you can get 10 marks. Easily can get 10 marks. From which question? I think question number 4 is easy, right? Question number 3. Question number 4, I think is very simple, right? Try with the question number 4. Customized subnet mask. What is the customized subnet mask? Slash 27 are customized. 24 we know, right? Slash 24 is a 255.255.255. 27. We need a more 3. 3 more means what? 128.64.32. 2, 2, 4. This is the answer. Question number 4 answer is what? 255 dot 255 dot 255 dot 220. 4 is a customized subnet mask, right? All of you? Is it clear now? Question number 4. Question number 4 is okay means remaining all questions are easy. Even you got the answers of remaining all questions simply. You know how? Let me write subnet mask 255 dot 255 254. Can you write 224 in the binary language, please? Tell me 224 in the binary language. 1, 2, 3, 4, 5, 6, 7, 8. Right? So first three bits are network bits. Finished. Now you can answer all the questions easily. So what is the first question, guys? Question number 1 is what? Number of subnets. So number of subnets means 2 power number of network bits. How many number of network bits are available here? 3. So 2 power 3 is much? 8. 8 subnets is answer. Right. Question number 2. Total number of hosts. So for total number of hosts means 2 power number of host bits. How many host bits are available? 1, 2, 3, 4, 5. So 2 power 5. 2 power 5 minus 2. 2 power 5 is 8. 32 minus 2, 30. So total number of hosts are 32. Number of valid hosts are what? 30. So number of subnets are 8. The total number of hosts are 32 minus 2, 30 valid hosts per subnet. Right? So finally, last question answer. Is it valid IP address? Yes or no? Last question answer. Tell me, guys. Mustafa, no. Why? Adip S. Why? Ram S. Why? Mustafa, can you tell me why it is a invalid? The telling is no. Yeah. Let me explain here. Example is 192 dot 168 dot 63 dot 0. 192 dot 168 dot 63 dot. How many number of host bits? What is the least converted bit? Least converted bit is what? 32, right? So 63 dot 32. Again 192, 168, 63 dot plus 32. 64. 63 dot 31. 63 dot 63. So 63 dot 63 is what, guys? Broadcast ID. Okay. So the same question is asking 192, 168, 63.63. So is it valid IP address? No, it's a broadcast ID, right? Now we can got out of 50. 50 out of 50. So like this, very simply, we can do based upon the slash notation, submitting, easy submitting. So finally, we can see one more example and we'll close the session now. Okay. 192, 168 dot 10 dot 16 slash 29. Is it valid IP address? Same question. The question. You tell me answers. Do it fast. First, you can copy the first one. Copy it. Right. This is the task for tomorrow. You try to practice on it. With answer. So today we have finished about subnetting concept. So yesterday we have finished about what? Static routing. And tomorrow we'll go with dynamic routing. Dynamic routing. We yes complete this week. This week we'll go with only dynamic routing only. All sessions for only dynamic routing. 32 subnet, 6 valid host. Okay, right. Okay, so my question is 10.16/29. Two 48. Okay, Ram. Anyhow, there's a task for tomorrow. Can do the practice. Clear, all of you? Any more doubts today regarding classes? So static routing and dynamic routing. Today, your task is try to do this scenario and static routing. I already informed you static routing advantages and static routing disadvantages. Anyhow, tomorrow we'll continue with difference between static and dynamic routing, and we'll go with dynamic routing up to complete this week up to Saturday. We'll continue with only dynamic routing. So once dynamic routing is done, the next week, hopefully, the next week, let me start about switching classes. If once switching is done, then we'll go for advanced security topics like that. Okay, guys. Okay. Thanks to all of you. Again, thank you all of you. Meet you tomorrow the same time. Thank you. Next one is router configuration. What do you have doubts?